Hey everybody, thanks for coming. My name's Holden Oullette. I'm very excited to be back here at ElixirConf. It's been great to see some folks again and to meet others in person for the first time. So my talk is titled Securing the Future, a roadmap to making Elixir the safest language, which I will admit sounds a bit grandiose, as there's a saying in security that there's no such thing as the perfectly secure system. But today I want to focus on some of the areas in which I feel the ecosystem is a bit on the weaker side, from the perspective of a security engineer who has personally had to secure very large Elixir and non-Elixir code bases. Some of the problems outlined by this talk are definitely not unique to the Elixir ecosystem by any means, but with the rate of adoption and innovation within our community, we have the potential to solve these problems for ourselves and in a holistic manner that the entire community can get behind. The goal of this talk is not to criticize or call out any author, maintainer, or creator within our community. So much hard work and care has been put into creating the very ecosystem we're here to celebrate. And this talk is purely my best efforts to lend my skill set to the community. With this presentation, I simply wish to shed a light on issues that may be lurking undetected. My hope is that by first outlining each problem and then discussing potential solutions, we can move quicker as a community to resolving each issue appropriately. Many of these ideas or discoveries are items that I would love to work on myself, but unfortunately it's more than any one engineer can take on by themselves. So it's my hope to sort of lay out a call to action to see if anyone is willing to pick up the torch and run with any of these issues. So one last warning before we start. By the very nature of discussing specific insecurities in technology, whatever shape that may be, I run the risk of not only ostracizing myself for highlighting issues that may not have a preventative solution in place yet, but I do increase the likelihood ever so slightly that some sort of malicious threat actor sees this and takes inspiration from it to conduct their nefarious plans. Now, I am happy to say, and hopefully Jose is happy about this, I'm not introducing any 0 days today or previously unknown vulnerabilities like you may see at some sort of security conference. But I will be discussing ways that threat actors can abuse the ecosystem in its current state to cause harm. And as I will be showing a demo today on how one could inject malware into developer machines that works as of today. So if after this talk I haven't yet convinced you to build out some of these potential solutions, my hope is at least you can go back to your teams and have some sort of constructive conversation about security in your tech stack. All right. Now with that tease of what's to come out of the way, a brief overview of who I am. I'm a staff security engineer at Okta. Previously, I was a security architect at Podium, which was a pretty large Elixir shop. I'm currently the maintainer of Sobolo, which is the Elixir security application testing tool. I contributed to SimGrup earlier this year to help support that, which is another SaaS tool. I presented a couple years ago at ElixirConf. I'm also a member of the Erlang Ecosystem Foundation Security Working Group. And then in my free time outside of security and Elixir, I like coffee and playing pinball and watching hockey. So feel free to chat with me about any of those afterwards. So my thesis, simply put, is that while there may be ways to provide solutions for some security issues, you as a developer or company shouldn't need to have a security-focused individual on a retainer to solve these issues. Now, in order to keep me employed, a security engineer can do more than just poke holes in an application stack, so you should consider hiring one for other reasons, but it's besides the point. The language and ecosystem itself should provide those secure elements out of the box, or if a solution doesn't fit in that box, the paved path for it should be singularly made and adopted. While we won't be focusing too much on any specific compliance requirements today, such as NIST or GDPR, many of the topics we'll go over do play a part in acquiring those different compliance certifications. So we're going to be covering a lot of areas across much of the Elixir ecosystem today. So I'll try my best to explain along the way and make it flow naturally. But 30 minutes is 30 minutes, and we've already taken up 5 minutes. So feel free to reach out to me afterwards, and I'd be happy to chat or listen to why maybe I don't have to worry about something because I overlooked something, because that happens sometimes. But let's start with the supply chain. Now, this is something that many of you may be familiar with already. You may even be familiar with supply chain insecurities. It's been in the news, unfortunately, a lot lately. There's even been executive movement on this topic surrounding memory-safe language usage. So it's something that's pretty prevalent today. But there's so much that actually goes into supply chain that it's easy to conflate issues with one another. Take, for example, the Target hack from a few years back. Attackers installed malware on the POS systems via a compromised third-party air conditioning vendor that had devices attached to the network. Compare that to the XZUtils backdoor from earlier this year, where a dormant good contributor tried to sneak in a network backdoor into a compression library that's present in almost every Linux distro. Now, luckily, that one got caught before making it out of some development releases, but it almost didn't. So both of these examples are supply chain vulnerabilities. And I could keep going with various real-world examples because they're really fascinating, but let's go over more specifically the areas we'll be focusing on with a security lens. The software supply chain simplistically can be viewed like this. We have two separate areas that we have to worry about in the supply chain: source integrity and build integrity. Now, upon looking at this image, how many unique areas of concern do you think there are in the context of security? Just shout out a number. 5? All right. There are 8. Yeah, a developer can intentionally or unintentionally submit bad code. Your source control could become compromised. You could accidentally build from an altered source. Attackers could compromise the build process itself. You could install a bad dependency during the build process. CI/CD could be bypassed or credentials leaked. The package repo that you're uploading or downloading from could be compromised. And then finally, you could just be using a bad dependency. So there's a lot of attack vectors to worry about. And it's something that I would hope, as a consumer of any language or ecosystem, that my chosen tech stack has some protections against all of those things as to not have to worry about them myself. Now, I think you may be seeing where I'm going with this. So let's talk about some of the deficiencies in Elixir today regarding the supply chain. Now, for the sake of time, we won't be talking about a few of these areas, like compromising source control or compromising the build processes, but there's still good things to think about and reflect on your own processes internally at your companies. Some other areas, like developers submitting bad code, will sort of partially be covered in one of our other sections about paved paths later. So let's dive into the concept of using bad dependencies as part of your build process, which starts off with a rather simple insecurity from our very own mix generator for Phoenix releases, specifically with the Docker flag. Now, there isn't anything obvious about what's wrong with this Docker file. It's doing the right things in regards to multi-stage image building. It's updating its dependencies. There's no extra ports open, nothing like that. But when you run the container image through open source security scanners like Trivy or even enterprise solutions, it's littered with vulnerabilities, primarily stemming from the underlying Debian image being used. Now, both the builder image and the runner image have container vulnerabilities with 4 critical severities and 6 high severities. Now, does it scare you even more to know that that count of 10 is only when we ignore the unfixed vulnerabilities? So if you were to include those, you'd have 138 known vulnerabilities in the builder image, and 132 in the runner image. Now, I want to give a major asterisk here. If you're not familiar with the types of vulnerabilities that are being surfaced here, it's worth explaining that the scanners are a little eager in their totals. Some of those vulnerabilities will get fixed when you run your first apt upgrade, or while others are potentially just an underlying component that can't even be accessed internally, or it's leveraged, or it's accessed via a component that you aren't using in your stack, so you aren't necessarily susceptible to it. Now, the tricky issue with that caveat is that there are so many vulnerabilities here that unless a team of security engineers went through each one manually to verify you're not susceptible, you just wouldn't be able to know if your system's vulnerable or not. And they keep coming in every day. Unfortunately, many of these enterprise and open source scanners are also used as audit sources for compliance purposes. So the results will show up regardless, and then you have to justify why you aren't vulnerable to auditors, and then it becomes a huge mess. The crazy part of this for me is that the primary culprit here is Debian, right? But even this image that's being used is a relatively up-to-date version. Even the most recent version of Debian has unfixed security issues. So what even is the solution if these container scanners will always trigger? Well, this is a chance for me to promote a pretty nifty company called ChainGuard, who solves this issue by providing secure container images for developers to deploy off of. Now, before you scoff and think I'm here just to promote a company. I promise I'm not getting any sort of kickback. Besides, the core of their technology is open source, and the governance for it is intended to have the community take it over time as soon as folks step up. I won't bore you with the nitty-gritty details, but it works sort of as an undistro, and they compile various images across the tech stack covering common use cases. Notably, they already support a base image for Erlang, which is completely free of container vulnerabilities. And that even includes those pesky unfixed ones. They patch them themselves as soon as they're announced. So ultimately, my proposed solution for this overall issue is to expand on the base image that they've open sourced, called Wolfie, to support Elixir out of the gate, and consider adopting it for the Phoenix release generator instead of using Debian. So as it stands, Hex published tokens are currently a very lucrative target for attackers in our space. Now, luckily, they can be scoped to only the permissions they need, but you can create an infinite number of them, and they never expire, meaning the token on that one laptop you upgraded from in your closet may still have write permissions to your packages. You can manually revoke those tokens, but if a token is exposed to the internet, A, there's no way to be notified that it happened, unless you're specifically looking for it, and B, there's no API to enable revocation of said token. Now, luckily, there is an open issue for this in Hex, and the team is incredibly supportive of that work, and it isn't a ton of involved work, since we'd be leveraging the GitHub automatic secret scanning infrastructure, where when they detect a token, they reach out to the package repository and say, hey, disable this token. It does require some changes to the formatting of the Hex token. We have to prepend Hex underscore onto it, but the work just needs to be done. And then finally, one of the other ways we can improve Hex token security is through this concept of trusted publishers. This is pretty new to the Python ecosystem, but essentially they leverage OIDC tokens to enable one-time use tokens as part of your build processes. So there's not actually any manual need to publish yourself, your packages. You can build it into like GitHub Actions and such, and it does a verification system, and it gives you a one-time use token. It's pretty neat. Again, luckily, the team is aware of this through a GitHub issue, and work is starting to happen to support the OIDC spec through the work of Jonathan from the Erlang Ecosystem Foundation's security working group. All right, so how do you know that a dependency you're about to include in your project is secure or good to use, especially if there's multiple options out there? The Open Source Security Foundation is a relatively new organization formed to collaborate and improve upon open source security and therefore the supply chain. I know some folks are unsure about how they feel about the organization at this point in time, but I personally believe that any organized effort on this front can only be beneficial and allows for new ideas or approaches to flourish. Two projects that I think are worth calling out from the OpenSSF that we can look towards implementing, or at least taking ideas from, are the Criticality Score project and the Best Practices Badge. The Criticality Score is a mathematical equation to derive some semblance of importance for a given open source project. The idea behind this is to determine which projects folks in the community depend on the most, and from there, giving a certain rating, one could derive potential security requirements for said package to implement in order to be published on Hex. Now, you may be asking, what would those requirements be? And that leads into the Best Practices Badge. Now, it outlines various prescriptive ways that open source projects can highlight that they're following the secure guidelines for building and publishing packages. All right, so now is the promised time. So we'll see if we can make this happen live. I should be connected to Wi-Fi. I'm going to demonstrate a vulnerability that sort of builds off a lot of the ideas that we just talked about with the supply chain. It's something you may be familiar with called dependency confusion. So let's see. Mirror. Ooh, let's not break everything. Okay, can you see this? Are we good? Cool. Yeah, of course. Thank you. This is an incredibly basic mix project. It's not even Phoenix. It's just something for us to load dependencies into. But we can imagine this is our code base. I am an Elixir developer. Maybe I'm new to the team. Maybe I got a new laptop and I'm just setting it up for the first time. But commonly, Hex has this concept of private packages, right? You can see here from the second line, my organization, Electric Samurai Security, has an internal private package called depth confusion. Now, because it's private, I have to be authenticated locally in order to be able to download that, and that happens through the command line. Now, if you're not logged in, you can only access things that are publicly available. Now, if there happens to be another package named the same thing as your internal package, it will download that without meaning to. Now, this is really hard to protect against, right? Because what are you really supposed to do? And we'll kind of talk about that here in a second. So let's say I'm a new developer, and I'm told through our internal wiki that I can download and install this. I know that there are command line options for me to download and specify that I should download this from the organization, but maybe I forgot to do that, and I'm just going to do a mixed steps to get or something. So let's try this out. So I'm just, okay, I need to download this. Oh yeah, of course. So we'll mix deps get. Sweet, downloading. All right, let's start our dev work. Let's get into this, and oh, cool, I've been pwned. And that's it, right? Because this bad package has some code in it that automatically ran when the module was loaded. It starts up its own application. It's all the logic's controlled in the package itself. And because I am an Elixir package, a malicious Elixir package, I have the full functionality of the language at my fingertips. And I would reckon to guess, I have yet to do extensive research on this, but I'd reckon to guess that the behavior that would be exhibited from the program running, such as scraping the files on your local file system, including your hex tokens or maybe your SSH keys, and sending them off to some command and control center remotely, wouldn't trigger most enterprise endpoint protection solutions because it looks like a developer process. So this is really bad. And when I was messing around with this, I also noticed that if now I'm like, oh shoot, I did this thing, I need to go fix it, and I go and I change this. If I don't fully flush out my dependencies, it won't go and download the new one either. So you still have the malicious one installed. So yeah, so how do you protect against this, right? This is kind of up to the user. And the company to kind of inform the developers of this. But that is sort of the breakdown that I want to call out here, right? Is we should try and ideate on some sort of better way to do this, right? And I think there are some compromises you can make that always run certain risks. If their private package is made in Hex, you could reserve the namespace, and if somebody tries to create a public version, it just won't let them. Obviously, then that could expose sensitive information, but that's kind of the risk. That's the trade-off. It's okay, would we rather expose that or have this happen? So, or have the likelihood of happening. You can also do things to reduce the impact of this, as I talked about with the hex tokens. If we sort of scope those down, or lean on paths like the OIDC tokens and move away from local tokens, local admin tokens, then you reduce the risk of this, the severity of this vulnerability in general. Because the likelihood is already reasonably low. You need to have some sort of insider knowledge about what a package is named for a company, but that's insider information. If some malicious person or disgruntled individual leaves their company, right, they have that information forever, unless the package name changes. So, yeah, anyways, hopefully that all makes sense. Let's go back into mirror mode. Or not mirror. All right, hopefully that worked. Are we good? Sweet. So with that fun demo out of the way, let's jump into the idea of paved paths, which is the idea of not allowing for any ambiguity in how to approach implementing some sort of feature or functionality as to allow the accidental inclusion of insecurity. Whew. A simple example would be a security team that provides like a library that mitigates a specific vulnerability class that they can instruct developers to just use that library and not have to worry about the vulnerability anymore. Now, many of the ideas presented in this section are typically more associated with business logic. So you may ask, like, why should we worry about this in a more generalized context? And my argument is that these ideas are complicated and they're hard to implement securely. Yet they share characteristics that are common across different implementations, and therefore there may be some room for introducing solutions at a broader level. Now, the fact that the community has built generators for things like authentication is a perfect example of this. So this section deals with introducing some problems where mixed generators may be the most apt solution. Others just need maybe a community-adopted official library. And finally, there's still some more room to potentially integrate some of these ideas directly into the language or frameworks within the ecosystem. So obviously, AI and LLMs are the new hotness. So I'd be remiss not to address something in that area. How many of you have heard of prompt injection or response hallucinations? Yeah? There are a number of different ways that LLM-based systems can receive user input and can be manipulated to potentially exposing prompt information at best and leaking sensitive credentials or performing malicious actions at worst. You can try and combat this with careful creation of your systems, whether that's allow listing input into the prompts or crafting protections into the prompts themselves, but each has its drawbacks and considerations. One of the things I've noticed about the Python community's approach to AI frameworks like LangChain and such is that it follows a pattern of do this and then do that and then pipe your response into this, and something that feels vaguely similar to us in Elixir land. One such library they have in the LLM field is called Guardrails AI, which is a framework which provides input-output guards in your application that detect, quantify, and mitigate the presence of specific types of risks. In addition, it helps generate structured data from LLMs. Now, there's a ton of this library. It's really cool. It's really neat, but it's Python only. They are open to supporting Elixir, so that is one solution, is to reach out and try and extend support for Elixir. I think personally that we already have this sort of structured data response problem mostly solved through efforts like Instructor EX. If you haven't checked that out, it's really cool. But what about if we had a suite of IO guards to protect against the litany of manipulation efforts, and it was built for Elixir, right? Food for thought. All right, let's talk about authorization. Now, authorization is probably the hardest subject to make a generalized solution for, since it's so application specific and depends on your business use case. That doesn't mean that we shouldn't leave developers out to dry to reinvent the wheel every time when it comes to auth-C. There's a reason why authorization-related issues are the #1 security issue as reported by OWASP, and anecdotally, it's the issue that I see the most frequently in the Elixir space. There's a number of solutions out there that I believe pave a nice path, some of which I can't discuss since they're sort of proprietary methods, but I would strongly recommend you check out the Petal framework, which has a pretty nice approach to, and a pretty nice Phoenix first approach. I've also heard good things about Ash framework's out of the box approach, but I haven't had a chance to mess with it too hands-on yet, so I didn't want to dive into that too deeply. Another solution that I am partial to is the approach OpenFGA takes. Now, OpenFGA, or Open Fine-Grained Authorization, is an open source solution that can provide a flexible means of assigning authorization using whatever system makes sense for your application, whether that's role-based access control, or RBAC, attribute-based access control, ABAC, or relationship-based access control, which is also RBAC, but I think it's REBAC. It can support it all. Now, I want to caveat before you go dive in and you plan your team's next sprint. There are a few caveats to OpenFGA. It's a pretty heavy project. It's heavier, and by heavy I mean it takes more than just including it as a package. So it's not really suited for like hobby project use, but the issue is that if you need authorization, you're going to build your own thing because you're like, oh, I don't need this yet. And then by the time you need it, it's going to be really hard to migrate your whole system onto it. So we need to have some sort of path to onboard onto a solution like it easily and quickly. And then the other pretty big caveat is that there's currently no SDK for Elixir. Now, the good news here is that OpenFGA was actually originally built by Auth0, which is a company that's been integrated into my current company, Okta. So I may know some people to have a pretty good leg up on tracking some folks down on how to get it officially supported. But also, their documentation is really good, and it's an avenue I'm thinking about exploring here soon. But I would love some help there. Also, now to avoid bias here, while a while ago the project ownership was transferred over to the Linux Foundation, so there shouldn't be much conflict of interest, especially since you can completely self-host the separate Auth0 service that OpenFGA requires. And also for context, it's based off the Google Zanzibar project, if anyone's familiar with that. So it's pretty tested at scale. For our last section, I'd like to turn our attention to the current state of security testing tools for the ecosystem. I've spent a lot of time in this realm, and while trying to implement a robust, secure software development lifecycle, I found these areas to be lacking for the Elixir space. And I think they are ripe for someone to come in and provide the missing pieces. So first up, we have static application security testing, or SAST. Currently, there are only a handful of working solutions. Soblo, which is Elixir native, and SymGrep, which support is only very recent. It's a great start to have some options in the space, but their limitations should be acknowledged and understood to better realize the direction we need to go in. SAST tools primarily work by identifying insecure code patterns when parsing the written code itself. So this means a few deficiencies arise. If a pattern isn't written, it won't detect it. It seems pretty obvious, but this is important to call out because there are some insecure settings that we don't have rules for built in the current solutions. So I'm thinking about examples like insecure nerve settings. I know those are outlined in the documentation, like, hey, don't do this. But if we know we shouldn't do it, we should also probably test to make sure we're not doing it. Leaving, if you purposely enabled the flag to leave sensitive headers in your Beam files when you compile on release, you should probably be notified that you're doing that. You might be pushing that to production when you don't mean to. And then almost as a sub point, one of the deficiencies in SAST is that it won't detect brand new vulnerability types. So, only vulnerabilities introduced by the inclusion of bad practices and known bad practices will be detected. We're not going to discover some crazy new vulnerability class in Elixir through tools like Soblo and SymGrep. Only after they've been discovered can we build rules for them. SAST findings can be incredibly false positive prone. Take, for example, Soblo, which was designed for this to be the case. It was originally built exclusively for security engineers to aid in their research for securing Elixir projects, but it's sort of since been transformed and adopted by the community as a way to run it in their CI processes to, actually be able to detect things. And I think it's really cool and it's neat and we should do that, but that's the methodology behind the false positive error rate, essentially. If a tool is too noisy, it creates too many false positives, and that introduces too much developer toil and can leads to findings being ignored. When a tool like Soblo or SymGrep are run in CI, only while you're trying to deploy, the developer feedback comes too late. How many times have you been under the crunch to get a bug or feature out the door, and you're faced with a blocker in CI, and you're like, oh god, why? Or maybe you've been given an optional warning, and you're just like, oh, I'll deal with this later. Part of that problem is you weren't given the context to consider sooner. And there have been many signs that getting the feedback to developers as early in the process as possible leads to less costly security bugs. Now, a shining light in all of this is that Elixir itself and the frameworks within it aren't super prone to certain types of vulnerabilities, which itself leads to the deficiency of SAST tools, right? Because if there are fewer things to action off of, then there's fewer things to raise attention to. It's just, we're calling out deficiencies here. And then the final one I want to call out is the simple fact that the tools won't work if people aren't using them. It's understandable and true of most CI tooling, but if you forget to include a linter that applies like a style guide, like a company style guide or something, your main risk is that your code going to production is maybe a little ugly, right? But if you forget to include security checks, you run the risk of deploying code that could be exploited. So how can we address these? Well, there isn't any one great solution, but here's what I think we could iterate on. Giving developers the security context they need as quickly as possible and as accurately as possible should be paramount. Two of the earliest points in which we could provide such feedback would be in the compilation step, or even better, in the language server. Now, implementation details would be complex and are a little nuanced, since security testing can often impact developer velocity in the form of slower compilation times, which wouldn't be ideal and kind of go against everything that the team is trying to work on. We could also explore like optional compiler arguments, but then you're on the risk of bifurcating the community, right? And then that doesn't include the concerns around false positives. How could you improve SAST in that regard? Well, in the SAST field, you have this concept of taint analysis, which is understanding how data flows from sources to sinks. Data gets tainted when it touches a questionable function. So an example that exists today, Soblo may detect that you're using a function that's commonly associated with code execution, which would be bad if you're passing in unsanitized user input. But currently, Soblo has no way of knowing whether or not the variable or data being passed to it is user controlled or not. If you could determine that, you'd be able to more confidently assess whether it's a false positive or not. So taint analysis is more or less the holy grail when it comes to SAST. It's a feature that SemGrep is kind of working on and has had some success with in a generalized way, but that support isn't ready for Elixir yet. So now, in the past, there have also been some languages that actually support taint analysis within them, and therefore an approach like that could aid in reducing the risk of false positives if we were to integrate SAST into the compiler or something like that. Okay, so I'm running out of time. But we have, so now on the sort of complementary side of SAST, we have dynamic application security testing, which is testing for vulnerabilities against running application through active exploitation attempts in a controlled manner. So what are our current options? None. There are a few off-the-shelf solutions that you can kind of mold to test against REST or GraphQL APIs. That's how sort of DAST can work. It doesn't need to know context, but nothing that benefits from providing the additional context that knowing it's an Elixir app could gain it, I guess. The primary reason for this is because it's good enough for compliance, and I say hogwash. And if you're looking for more protection than just checking off a compliance box, then I'd argue that there's space for a new solution to be made that leverages some of Elixir's capabilities. As we all know, Elixir's first-class support of documentation and testing leads to the robust ecosystem we have today. I'm willing to bet that we could leverage that in combination with the strengths and approaches SAST tools like Soblo use to create something new and specific for Elixir. Now, there's this concept of interactive application security testing, or IAST, which is essentially a combination of the two approaches, SAST and DAST. One in which SAST sort of insights provide the focus context to the DAST tool to try for more complex exploits that would lead to more true positives. My intuition is to utilize the emphasis on best practices for function definitions and documentation to craft some sort of tool that can produce artifacts in which to provide a DAST tool for better context. This obviously is still very rough and needs more shaping, but it could potentially take the form of a completely separate tool, or maybe even just like a test harness generator that focuses on creating abuse cases in code. Now, if we were to take the latter approach, we'd also benefit from building in a regression testing suite to ensure that issues aren't reintroduced with future code changes. We also have RAS, which is the final area of security testing I see a gap in, which is run application self-protection. Now, Paraxial is awesome for open sourcing kind of the first thing out there for RASP, for Elixir specifically, which is a runtime monitor that hooks into live applications and either monitors or blocks processes that are attempting to perform remote code execution. But I think that's just the start. There are further opportunities to improve on solutions like Exploit Guard and potentially even make additional solutions, such as in-app cost-wasting protections, web application firewall like behavior running at the application layer, and potentially even basic levels of DDoS protection. All right, that was a lot, and I'm out of time. So, in summary, there are a lot more opportunities for us in the ecosystem to encourage stronger defaults and create paved paths. There's a ton of room for someone to come in and provide a solution for complementary solutions like libraries, tooling, etc. These insecurities are big language problems, and we should solve them before we're backed into a corner, i.e. the adoption of Elixir is high enough to warrant the attention from bad actors. It's going to take all of us to put our security hats on and improve the ecosystem together. And we do have a chance to build an ecosystem that can cleanly allow rapidly growing companies to become secure from the get-go. I dream of a boilerplate starter project that is already certifiable by things like NIST. I wanted to talk about a whole lot more. Since I'm at time, these are all things that were originally scheduled for the talk, and things I want to go into that I think are missing or need improvement on the ecosystem. So if you're interested in learning more about these things, consider following me on X, I guess, is Twitter, or supporting my work on GitHub. I plan on documenting all of my sort of continued explorations there and on my blog and through other conference opportunities. So thanks for coming, everybody. Appreciate it.